In advance I would like to apologize for my pronunciation during this video, seeing as I am a text-to-speech program that is not perfect. Thank you and enjoy. The theme that I have chosen is economic transformation. I will be answering this essential question. In the recent decades and those to come, how has 3D printing technology changed the way that people make industrial and artistic products? The basis of all 3D printing is in the code. This code tells the printer exactly where, how fast, and how much filament that it needs to use. The most common code for 3D printing is G-code, which was first created in 1950 at the Massachusetts Institute of Technology for Computer Numerical Control Machines. Today it is now the most commonly used numerical control programming language for most workshop machines. While G-code has been around since the 50s, 3D printers were not invented till 1986 when the first patent was created by a man named Charles Hull. Today he is the co-founder, executive vice president and chief technology officer of 3D Systems. He is the official inventor of the solid imaging process known as stereolithography, the first commercial rapid prototyping technology, and the STL file format. He is named on more than 60 US patents as well as other patents around the world in the fields of ion optics and rapid prototyping. He was inducted into the National Inventors Hall of Fame in 2014. There are 9 basic types of 3D printing styles. The first and most commonly used is the FDM printing method in most desktop 3D printers. Thermoplastic filament is heated and extruded through an extrusion head that deposits the molten plastic in X and Y coordinates, while the build table lowers the object layer by layer in the Z direction. The second method, which was created by Chuck Hull, is called SLA. It works by exposing a layer of photosensitive liquid resin to a UV laser beam so that the resin hardens and becomes solid. Once the laser has swept a layer of resin in the desired pattern and it begins to harden, the model building platform in the liquid tank of the printer steps down the thickness of a single layer, and the laser begins to form the next layer. Each layer is built on top of the preceding one. The third method is called DLP. This technology was invented in 1987 by Larry Hornbeck of Texas Instruments and became extremely popular in projectors. DLP uses a computer-controlled, micro-mirror grid, laid out on a semiconductor chip. These tiny mirrors tilt back and forth. When a mirror is tilted, it reflects light, creating a bright pixel. When the mirror is tilted the other way, the pixel is dark. The technology is used in movie projectors, cell phones, and also for 3D printing. One of the benefits for 3D printing is its speed. You can print layers in an instant with this type of 3D printer. The fourth method is SLS. SLS is similar to SLA, but the key difference is that this type of 3D printer uses powdered material in the build area instead of liquid resin. A laser is used to selectively sinter a layer of granules, which binds the material together to create a solid structure. When the object is fully formed, it's left to cool in the machine before being removed. The fifth method is SLM. SLM is sometimes regarded as a subcategory of the SLS 3D printer type, where SLM uses a high-powered laser beam to fully melt metallic powders into solid three-dimensional parts. Typical materials used are stainless steel, aluminum, titanium, and cobalt chrome. For applications in the aerospace or medical orthopedics industry, SLM is used to create parts with complex geometries and thin-walled structures, with hidden channels or voids. The sixth method is EBM. In contrast to SLM, the EBM technique uses a computer-controlled electron beam under high vacuum to fully melt the metallic powder at high temperatures up to 1000 degrees Celsius. This type of 3D printer can use metals like pure titanium, Inconel 718, and Inconel 625 to fabricate aerospace parts and medical implants. But while the 3D print technology is exciting, it's currently very slow and very expensive. The seventh method is called LOM, or laminated object manufacturing. LOM uses layers of adhesive-coated paper, plastic or metal laminates, which are fused under heat and pressure and shaped by cutting with a computer-controlled laser or knife. This is sometimes followed by machining and drilling. The 3D object is created layer by layer, and after the excess material is cut away, the object can be sanded or sealed with paint. The eighth method is binder jetting. Binder jetting is an additive manufacturing process. This type of 3D printer uses two materials, a powder-based, often gypsum material, and a bonding agent. The agent acts as an adhesive between powder layers. Usually, the binder is extruded in liquid form from a print head. Just think of a regular inkjet 2D printer. After a layer is finished, the build plate is lowered and the process repeated. The last 3D printing style isn't per se made for 3D printing, it is just improved by it. It is called wax printing. Molten wax is deposited onto an aluminum build platform in layers using several nozzles that sweep across the build area. As the heated material jets onto the build plate, it solidifies. A different type of wax with a lower melting temperature is deposited below overhangs in the product, acting as a support material. When printing is finished, they are put in a heated bath that melts away support material. This mold is then used to cast various types of metals. While there are a few types of 3D printing styles, there are numerous types of filaments that the standard 2 printers use. Here is a list of 30 of the more common types. "3D printing has been applied in medicine since the early 2000s, when the technology was first used to make dental implants and custom prosthetics. Since then, the medical applications for 3D printing have evolved considerably. Recently published reviews describe the use of 3D printing to produce bones, ears, exoskeletons, windpipes, a jawbone, eyeglasses, cell cultures, stem cells, blood vessels, vascular networks, tissues, and organs, as well as novel dosage forms and drug delivery devices. The current medical uses of 3D printing can be organized into several broad categories: tissue and organ fabrication, creating prosthetics, implants, and anatomical models, and pharmaceutical research concerning drug discovery, delivery, and dosage forms. 3D printing technology has the potential to make the manufacturing process options infinite and extremely precise. For example, today, using what's known as subtractive process, if you want a part made out of aluminum, a block is placed into a CAD system and the excess material is cut away to make the part. Using this process, approximately 60 to 70% of the aluminum block ends up as scrap depending on the complexity and shape needed. By contrast, 3D printing technology is additive, and manufacturers are able to use the minimum material needed to fabricate a part. In the example above, using a 3D printer could essentially eliminate the process of melting down excess scrap material and wasted resources, ultimately driving down total material costs for the manufacturer. For the manufacturing industry in general, this could significantly reduce capital tied up in raw materials and costs to reclaim scrap. There are so many hobbies where 3D desktop printing can be of use, especially when filament types are expanding. From candle making to model building, it is certain that 3D desktop printing could assist artists in their endeavors and possibly even enhance their creativity.
And 3D printing, same thing, really. You've got 2 printers now on station. Tell me where we are and where we're going.
Well, it's going to be a very exciting few years. We actually, under the Inspace Manufacturing Project, have a phased technology development roadmap of all those technologies that we're going to leverage. Space Station is an absolutely critical test bed. It is the only laboratory, crewed laboratory we have in microgravity to test all of this out and to get ready for those exploration missions. So now, as you mentioned, we have 2 printers. We have the 3D print tech demo that flew September 2014 that we're getting ready to start our phase 2 of operations. And we have the Made in Space additive manufacturing facility. The really exciting thing about AMF is this is actually a commercial printer that is owned and operated by Made in Space, Inc., out of Silicon Valley, California, and through the ISS National Lab and CASIS. Not only NASA will be using this printer, but other entities in industry, academia, other government agencies can all print on Space Station to manufacture parts. So not only will you see the first ever student design part manufactured on station, you'll see all sorts of exciting things.
That's all, folks.